the issue with number 15 is that it's got 3 parts to it. But basically, I'm going to start off with this, okay? And that's a box method thing, or a FOIL, however you want to do it. So 3x minus 2 is going to be multiplied with 4x plus 5. And just go ahead and fill in your box like you normally would, right? And so we have 12x squared. And I've got 15 and negative 8, which makes 7. And then we have negative 10, right? Then what we're going to do is we're going to multiply the 7x as well. So that's the last thing I'm going to recommend is distribute the single number into the whole thing. So you'd get your final answer that way. So that's for number 1, or number 15 there. Okay. So that's how you handle that. The only issue, the reason why I like to go over this one with you guys is because a lot of people, they try to distribute this first, which technically is possible, but if you're going to do that, you would only do it to the first one. You wouldn't do it to both, because if you do that, you're double multiplying that value. That's not how you do it. You'd be over multiplying, so you don't do that. All right. The next two, you could do the box method with these and get the right answer, but there's shortcuts that we learned, and it's nice to keep those things sharp. So whenever you have 2 binomials that are exactly the same, but they're opposite signs, you don't have to do the box. What you could do is you could just do the 2 first terms multiplied together. 2x times 2x is 4x squared. And the 2 last terms multiplied together, negative 5 and 5. And that'll be good enough. The box will work. The reason why the box will work anyway is because basically when you do the box with these kinds of problems, since these 2 things are exactly the same but with opposite signs, you end up with the same thing in these squares, but they're opposite signs, they just cancel. So that's why we really only care about the first and the last term, because the middle ones cancel. This one over here also has a shortcut to it, but before I get to the shortcut, I'll share with you guys common mistakes that I see with this. Common mistake that I see with this one is people like to distribute this power in here, and they like to say, okay, it's 4x squared plus 1, and that's wrong. Okay? It's not how it works. What you do with this one is you have to understand that it's actually squaring the whole binomial, which means you're multiplying that binomial by itself, and that actually makes it a box problem. Okay? So, now there's a shortcut though. Just like this one has a shortcut, when you have 2 of them that are exactly the same, just opposite sign in the middle, you do this. This one's pretty similar. You're still going to do the first ones multiplied together. You're still going to do the last ones multiplied together. But we need a little bit more. What's going to happen here is you're going to take these 2 in the middle. You're going to multiply those together. What's 1 times 2x? 2x. And then you're going to double it. So what's 2x doubled? 4x. And that's your shortcut. Okay? That happens because when you're multiplying 2 things that are identical, the 2 numbers that go in this diagonal are exactly the same. When you add them, it's like you double it. Okay? So it can save you a little bit of time if you want to do that instead of the box method. But like I said, if that's too much to remember for you, just do the box. You'll get the answer. The last one I'll go over is an example for number 18. So for number 18, I'm not going to do an example, but what I'll do is I'll set the problem up for you. So on number 18, we have this. So when you have a binomial multiplied with a trinomial, we're going to do the box again, but this time it's going to be a 2 by 3 box because we have a 2 by 3 multiplication. So it'll be x plus 1 and 2x squared minus 5x plus 1. You fill in the box just like you do over here. You still combine your like terms and all that sort of good stuff. So not much is really all that different after that. So I'm going to give you guys like couple minutes to work on 15 through 18, then we'll move on to the next part of our thing. So I'm going to move on to numbers 19 and 21, and I think for this set, I'm going to do the, actually, I'm going to do the even ones. I'll let you guys do the odd, because the even ones are a little bit harder. The odd ones are a little bit easier, so I want to do the hard ones with you, let you guys do the easier ones, because I'm just a nice guy like that. Okay, so this is a rational expression. It asks us to simplify it. So the way that you simplify is you factor and cancel. Okay? So for this top one here, what method would I use to factor that? You would use the box method because it's got 3 terms. Good job. So when they have 3 terms, that's a box method problem. So we have A and A, 7 and 5, plus and plus. Now I am skipping the work because we've already reviewed factoring. But if you have questions about factoring as you're working on this, just let me know. I'll be glad to help you. But what were you saying? Yes, I'm going to do the evens this time. Yeah. I'll let you guys do the odds. Okay, now as for the bottom, that's not a box problem because there's only 2 terms. Now, that means it could be a difference of squares or maybe just a GCF or maybe nothing. Is this a difference of squares? GCF. Yeah, it's a GCF, right? What do they have in common? 2. So I can take out a 2 and an A, good. And if I divide 2 and A out of both of those, what would be left inside? Second? Oh, you know what? We could take out 2 A's actually. I just realized that. Because this one has 3 and this one has 2, so you could take out 2 A's at least, right? So if I divide this by 2, I'm left with 1 and 5. And if you take out 2 A's, we'll be left with 1 A here. And we'll be left with 5 over here. Okay? After you factor, you cancel whatever you can from the top and bottom. Now you got to be careful though. You're not allowed to do this. Like if you have this, that's not allowed, right? Anytime a number is joined to another number by plus or minus, they are married. You can't take one out with taking the other one out. Okay? So the only thing that will cancel A plus B is A plus B. You can't take the A out of there.
Or divorce.
Yeah, we don't know divorce here. Now the people who do get divorced here are these guys. Multiplication, they can get divorced. They probably got married because they wanted happiness. Inside joke. Okay.
Inside joke.
Can I erase? This was an arranged marriage. You can't do anything about those. Still an inside joke. It's okay. You guys don't know, but me and Seth, we're homies like that. All right. Here we go. I have friends. All right, let's go ahead and take a look at number 22.
Now it's all high school students, so just beware of that.
All right. So these are fun. Oh yeah, these are real fun.
Oh, they are. I remember these.
What we have is we have a giant fraction, a big fraction. I want to use a different color. Hold on. A big fraction, which is this whole thing. That whole thing is one giant fraction with a numerator and a denominator. That's my giant fraction. But inside of that giant fraction, we have little miniature fractions, little viruses. We're going to cure the virus. We don't want fractions inside of the fraction. So we're going to get a, what do you call it? Vaccine. Okay. So I want to cancel. I don't want this to be a fraction anymore, right? So what would I multiply that by to cancel the A out? A, which is totally cool. You're allowed to do that if you do it on everything else. If you don't do it on everything else, you're unbalancing your fraction and it won't be the same anymore. Okay? So if I do that now, what do I have left on the top?
1.
Just 1. So now my numerator's been cured. It has no little infestation of miniature fractions inside of it. But on the bottom, we still have a problem. Nothing cancels here. I had some students in my last block doing this. That's a no-no, remember? That's the arranged marriage. They're inseparable. You can't do it. All right, so we have 5A over A plus 3 minus 25A over A plus 3. So you just, since we couldn't cancel, you just multiply it straight to the top. Okay? But we're still not done. We still have an infection here of little viruses inside, little fractions inside the big fraction. So we need to do some more vaccination here. So what am I going to multiply this guy by to cancel out the a plus 3? A plus 3, right?
Yeah.
Just like that. But you're only allowed to do that if you do it everywhere, even on the top. I'm not going to write the top one as over 1 because it's not a fraction up there. Now in this case, these will cancel, and now I'm left with a plus 3 on the top, right? And on the bottom we have 5a minus 25a, which simplifies into negative 20a. Good? So I will let you guys work on numbers 19 and 21 for a little bit, and then we'll proceed onward to the next part and the last part after a little bit. Now, this is an exponential function, you guys. You have this stuff in your notes, but if you don't want to bother flipping through notes and you want to just take some extra ones on your worksheet, you can. Exponential functions are ones that look like this. Now, when you graph these things, first of all, you want to find your horizontal asymptote. The horizontal asymptote is this number here. It's the C value. The next thing you want to do is you want to find your Y-intercept. Your Y-intercept is what you get when you plug in 0 for x. Now this is the long way to do it, but let's think our way through this. If you plug in 0 here for x, that's going to be b to the 0 power. And anything to the 0 power is 1. And what's 1 times a?
It's
A. So your Y-intercept is going to be a plus c. So that's your Y-intercept. So you don't have to plug in 0 anymore. You just remember it's always a plus c. Okay? The next thing that you're going to do is you got to pick out, you have enough information. After you graph your horizontal asymptote and plot your Y-intercept, you just got to figure out what shape you're going to connect those pieces with. And it's based on 2 criteria. It depends on whether b is greater than 1 or less than 1. And it also depends on something else, but let's talk about b really quick. When b is greater than 1, your growth factor, it's increasing. So your graph would look like this. But when b is less than 1, your graph is decaying, so it would look like this. Okay? Now, that's if a is positive, though, because when a is negative, from our transformations, we know that that just flips it over. So in this case, it would look like that. And in this case, it would look like that. Okay? So there's our steps. Let's go ahead and apply those steps to number 23 here. So first of all, what's my horizontal asymptote? Okay, so I'm going to draw a horizontal line here at -2. What's my Y-intercept? -6, because a plus c is -6. Now I got to figure out what shape to connect them with. My b value is less than 1, and my a value is negative. That would be this shape here. So I'm going to connect this dot with that shape so I get my asymptote over there. There we go. So that's how we graph exponential functions. And when worst comes to worst, guys, you can always graph any function really just by plugging in a whole bunch of dots and connecting the dots, right? But these are ways to make it faster and not so tedious. I'll get it from you in a sec. So that's graphing. The last thing I want to show you guys is I think I'm going to not do either one of 25 or 26 because they're both a little bit different. So what I'll do is I'll do 3 examples for you guys, and those should be helpful to you. So this is, for example, what? 25 through 26. Okay, let's start off with something basic here. 5 to the x equals 125. And I'll put a little, maybe I'll put a 2 there. 5 to the 2x equals 125. Okay, now we could solve this using logarithms. Okay, we could do that. And so if you want to use that skill, I don't mind. It's fresh in our minds from last chapter. However, I'm just going to solve it the way we did initially when we talked about exponential functions. You want these to end up with the same base. So what I'm going to do is I'm going to change 125 to be 5 to the power of what? 3. Good. Once you get the bases to be the same, you can just cross it off and solve what's left. Okay, so there's your basic strategy, but I want to throw a few other things at you here. Suppose that I had 6 to the x equals 1 over 36. Okay? So when you have a fraction, the first thing that you're going to want to do is rewrite it with a negative exponent. Then you match your bases. So 36 can be rewritten as 6 squared. Right? From there, we go ahead and multiply those together, and you can drop off the base. Okay? The final thing that you might want to be prepared to do, let's see, what's another one? How about 7, 3x plus 2 equals the square root of, okay, whatever, 7. So, for these ones, you got to remember the square root can be rewritten as 7 to the power of a half. Okay? From there, you would just solve this, and I was kind of hesitant about this because I didn't want to deal with the fraction, but I'll just go ahead and do it. So anytime we have a fraction, I like to just multiply everything by 2, and then I don't have fractions anymore. Right? So, but I don't know, that's kind of weird. You probably won't see that on yours necessarily. So anyway, but your strategies are match the bases. We don't like fractions, so give them negative exponents. We don't like roots, so make them exponents. Okay, those are your 3 things you want to keep in mind. So the rest of the worksheet's up to you guys. You've done what you can in class, and manana, the worksheet is due. The worksheet's due tomorrow, and we'll have our test on this stuff tomorrow. Okay. Today, Bible club today, but yes. Huh? That's fine. Sure.